So hello and welcome to another video from sickmaths.co.uk, where you'll find the whole of GCSE Maths all explained on video for free, so do check it out. This video is about cumulative frequency diagrams. So this is a cumulative frequency diagram with this kind of line going through dots. Forget the dotted lines for now, that's just explanatory stuff, including the arrows as well, ignore that as well. Okay, so cumulative frequency diagram is actually very simple. Basically it's just a line graph, except for normal line graphs use frequencies and I'm using cumulative frequencies. Okay, so what is cumulative frequency? Cumulative frequency just means you add up the frequencies. That's all really. Look at this. You start off with the same number, 2 and 2, okay? But then when I do add up the frequencies from here, so 2 plus 5 is 7, and then as I go down, I keep adding the frequencies. 7 plus 4 is 11, 11 plus 1 is 12. I'm just adding up the frequencies, cumulative frequencies, and that's all it is, a line graph using cumulative frequency instead of frequency. Okay, so let's plot it. I've got these weight categories. You can see I've written using inequalities. Hopefully that doesn't confuse you. There's another video on my website about inequalities if you need to know, but basically this is just saying weight categories between 3 and 0. Normally I should say if it's kilograms or stones or something, but I'm not really too bothered here. So these are your various weight categories. And what's next? So if I'm trying to make a dot for this whole weight category, where do I put it? Do I put it in the beginning, in the middle, at the end? Where? So for cumulative frequency diagrams, you put the dot for or the position for this weight category at the end of the weight category, so 3, okay, and then you use the cumulative frequency 2, so I go 3 across, 2 up, and I make a dot. And then for this one I go 6, I use 6 across for this weight category, and 7 up, so 6 across and 7 up. Can you see that 7? That's your next dot. Okay, for this one I go 9 across and 11 up, 9 across, 11 up, there's another dot. Can you see that's 11? And 12 across and 12 up, 12 across and 12 up for the last dot. These numbers don't have to be the same, by the way, it does happen to be the same. Okay. So anyway, you get your 4 dots in this case, so there's usually more dots to do than that. And then you just draw a nice curvy line, starting from 0. Always start from 0 for cumulative frequency diagrams, okay? And always use curvy lines, don't use a ruler, okay? And there's a reason why you have to use a curvy line. First of all, the dots will show you that it's a curvy line, not a straight line. And the reason why you could still actually just use a ruler like this, boing, 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 but that wouldn't really predict how the graph really should look like. And what you want to do later on with all these dotted lines is to predict what the data could be like if we had even more information. Now you're only going to do that if you draw the graph how it should be rather than just lots of straight lines, which is not really how it should be. Okay, so that's why you do that. Now, what else is there to explain? Let's work out the median. Now, the median, very briefly, I've explained it in another video, so if you go to the website and type in median, you'll find how to work out median generally. But so the median is basically the middle number, and it's slightly different to other situations, like with just normal numbers I work it out in a certain way, which you'll find on the website, and on box plots you'll find it in a certain way. On cumulative frequency diagrams, because we're only estimating, we do things very roughly, so halfway through 12 is 6, okay, so the 6th person's information roughly will belong there, and you go across dot 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 dot, and then go hit the graph and then go down down down, and the median will be this data here. So the 6th person's weight basically is the median, not number 6 but its weight. So his weight or her weight is 5, about, let's just say 5, okay, 5 stones. I haven't even said what unit we're using because it doesn't really matter in this situation. So 5 stones is the weight of the median weight of the person here, and that's it. No, sorry, it's the median weight of all the people, not just that person. Anyway, and what else? You can work out lower quartiles, upper quartiles over here. What are they? Basically, quartiles means cut the data into 4 pieces. So if you want to work out the quartiles, this is how you do it. Again, if you search quartiles, on this website you'll find another way of doing it with just pure numbers, but for cumulative frequency diagrams this is how you do it. You cut the data into 4 equal parts, so you got a total of 12 bits of data. So I do 12 divided by 4 is 3. So the first quartile is here. Quartile is basically something that separates the bottom 2 quarters. The lower quartile is the one that separates the bottom 2 quarters. The upper quartile is the thing that separates the top 2 quarters. The median is like a quartile if you want, but forget that. So the third person's weight, okay, is going to be the lower quartile. Let's just say that's 4 to keep it simple. It could be, I don't know, 3.9 or something, but let's just call it 4 because I'm going to use it later on in a second, just to make things simple. The upper quartile, let's just say that's about there. 12 divided by 4 is 3, times 3 is 9. So 9, the 9th person, that person's weight, okay, is the upper quartile. Let's just say that's about 7. Okay, now I might want to work out the interquartile range. So if that's 7, the upper quartile is 7 and the lower quartile is, we said, 4. 7 take away 4 is 3. So the interquartile range is 3. Okay, interquartile range, well, means the difference between the upper quartile and the lower quartile. That should make sense if you know what range means. Range means the difference between the minimum and the maximum. It's the difference. Okay, so this is the difference between the quartiles. Yeah, the interquartile range. Yeah, inter means between usually, or amongst, like international, whatever. So we've done quartiles, medians, interquartile range. Another common question is they might say, how many people have weight 9 stones or less? Oh, so it is stones. I should have put stones in brackets here, ST or something. Right, so how many people weigh 9 stones or less? Well, you start, since we're talking about stones or weight, you start from the bottom axes and then you go up to the graph and then you go across and you can see all this data. That's about 11, just say really roughly. Okay, so all this data is represented by people weighing 11 stones or less, because you have to remember this is cumulative frequency. So say this data here, all this data here, from going across from 4 and down, all this data represents the weight category is 4 stones or less. Because if I go back to this, if I say this is 7 people, the data from here on down upwards, represents these 7 people are in this category and this category. 11 people are in this category, and this category, or these groups, or whatever you want to call them, classes. Yeah. So the way cumulative frequency works is that it's this data and less kind of stuff. So let me say that again in a couple of different ways. So 11 people weigh 9 stones or less, and only one person therefore weighs over 9 stones. Okay, let's pick another point here. So, what's it called? I don't know what number that is. Say 7 people, going down from here, weigh 6 stones or less, and you can see that 7 people weigh 6 stones or less. Yeah, 7 people weigh 6 stones or less, because these are the first 7 people, and this is 6 stones to 3 stones, 3 stones is 0 stones. So from here to there, 6 stones or less, 7 people weigh 6 stones or less. So that's it really. Oh yeah, there is one last thing to explain. Why do you usually have an S shape? Okay, typically this is kind of your A grade A star bit of information. Typically what happens is most people are in the middle category. So if we're talking about weights, very few people are really light or really heavy. Most people are average, but by the definition of average, most people should be around that. Okay, which means when you're doing a cumulative frequency, you suddenly add loads of people in the middle groups, which means when you're drawing a cumulative frequency, you start off with hardly adding anybody from the 0 to the first category, and then suddenly you start adding loads of people, okay, which means the cumulative frequency diagram goes up really quickly and up really quickly. And then for the last categories, we've only got one last category because we've got only 4 bits of information, but then you hardly add anything else, so it slows down. So you can see that normally you'd get the situation where it starts off slow because hardly anybody's in the very light categories, and then you start adding loads of people in the middle categories, where the kind of like the middle averagey categories, and then you slow down again. So you always get this S shape unless you got some weird messed up data, which you sometimes do. They just test you, like, oh, what happens in this situation or that situation when you've got loads of people in the beginning or something. If you had loads of people in the beginning, then you would shoot up really quickly first, and you wouldn't have quite this S shape. You would have a weird shape like that, maybe. And that's it. Nothing else to say. Very simple video, but slightly long video. I mean, it's slightly long because I'm kind of explaining all these tiny things and possibly A-star stuff, which does come up, but it doesn't come up much for cumulative frequency because it's quite a simple topic.